Today we're going to be solving systems of equations by elimination. So recall that the standard form of a linear equation is ax plus by equals c. When both linear equations of a system are in standard form, the system can be solved using elimination. The elimination strategy adds or subtracts the equations in the system to eliminate a variable, to get rid of a variable. So a couple things we just need to look at. -2 plus 2. That's going to be 0. 3 plus -3, 0. -5 plus 5, -5x plus 5x, 0. 9x plus -9x, 0. All these are elimination. So looking at linear systems elimination method, so we're just going to look at the different steps to solve for systems using the elimination method. First off, line up all the x's and y's. You want to make sure the x's are on top of the x's, the y's are on top of the y's. Step 2 is you're going to look to see if one variable has opposite coefficients. So that would be like 2 and -2, or 5 and -5. They're opposites. If yes, then you're going to move to step 3. If no, we have to multiply one or both equations by a constant, the least common multiple, in order to make the coefficients of the x or y terms opposite. Step 3, add the equations together to eliminate one of the variables. Step 4, solve for the remaining variable. Step 5, substitute the value you found into one of the original equations to solve for the other variable. And step 6, write your answer as an ordered pair. So, how do you decide which variable to eliminate? First, you need to look to see if one variable has the same or opposite coefficients. If so, eliminate that variable. If the variables have the same coefficient, you're going to subtract the two equations to eliminate the variable. So for example, 3x and 3x, that's the same, so you subtract them. If the variables have opposite coefficients, you're going to add the two equations to eliminate the variable. So if it's 3x and the second equation says -3x, you add to eliminate. So here's an example. 5x plus y equals 44. -4x minus y equals -34. First, you choose which variable to eliminate. In the equations above, y variable has opposites coefficients, so that variable will be the easiest to eliminate. So you're going to add the two equations together. And step 3 is to substitute the solution into either equation and solve. So here we go. We're going to just move that. It's 5x plus y equals 44. 5x plus y equals 44. And the other problem is -4x minus y equals -34. So since we determined that the coefficient for y is opposite, we're going to get rid of the y and we're going to add the two, we're going to add the two equations. So 5x plus -4x is just x. Y plus -y is 0, so I'm just going to cross that out. And then 44 plus -34 is 10. So now that I have x equals 10, I'm going to take this and I'm going to substitute it in for one of the x's of the original equation. So I'm going to say 5 times 10 plus y equals 44. So 50 plus y equals 44. Then you have to solve for y. So subtract 50 from both sides. Y equals -6. So my answer is 10, -6. And if we want to check that, we would just plug them right back in. So I'm going to check on the second equation. -4 times 10 minus -6 equals -34. So -4 times positive 10 is -40, plus 6 equals -34. -34 equals -34. So my answer is 10. Let's look at this problem. I have 3x plus y equals 15, and negative 3x minus 3y equals negative 21. I have opposite coefficients on the x. 3 and negative 3 are opposite. So that's what I want to eliminate. And since they're already opposite, that just means I can add the two equations. 3x plus negative 3x is 0, so I'm just going to cross that out. So now I just take y plus negative 3y, so that's going to be negative 2y equals 15 plus negative 21 is negative 6. I solve for y, divide both sides by negative 2. Y is going to give me 3. And I just have to plug it back into one of the original equations. And it doesn't matter which equation I plug it in, so I'm going to plug it into the first one. So 3x plus 3 equals 15. I'm going to subtract everything by 3. So I have 3x equals 12. Divide both sides by 3. X equals 4. So I have 4, 3. Here's another one that we can look at. Do I have opposite of x plus y equals 6 and x minus y equals 4? And actually, I would go ahead and pause it so that way you can come back and look at it and work it out on your own and then come back and look at it. So here I have my opposite coefficients are my y's. So I'm going to add my two equations together because they're opposite. So I have 2x, y plus negative y is 0 equals 10. Divide both sides by 2, x equals 5. So then I'm going to have 5 plus y equals 6 because I'm just plugging what I found in to the original equation. So subtract by 5, y equals 1. 5, 1 is my answer. Great, same thing here. Go ahead and pause the video and try to work it out. We have 2x plus y equals negative 5. 2x minus y equals negative 3. I have opposite coefficients with my y's, so I'm going to add. 2x plus 2x is 4x. Y plus negative y is 0. Negative 5 plus negative 3 is negative 8. Divide both sides by 4. X is equal to negative 2. Plug that back in. So I'm going to have 2 times negative 2 plus y equals negative 5. 2 times negative 2 is negative 4 plus y equals negative 5. Add 4 to both sides. Y equals negative 1. So I have negative 2, negative 1. Now, if they're the same sign, you must actually subtract the two equations. So if I have 5x plus y equals 17 and negative 2x plus y equals negative 4, I have to subtract them. So you just put subtraction there. So 5x minus negative 2x is going to be 7x. Y minus y cancels that out. Negative 17 minus negative 4 is positive 21. This is where you really need to watch your signs. Divide both sides by 7, because 7x equals 21. So x is going to equal 3. And then I plug it back into one of my original problems. 5 times 3 plus y equals 17. 15 plus y equals 17. Subtract by 15. Y equals 2. So I have 3, 2. Go ahead and pause this one and work it out by yourself, and then we'll come back. All right, so I have 2x plus y equals negative 6 and 3x plus y equals negative 10. I don't have opposite coefficients, so I have to subtract them. 2x minus 3x is negative x. Y minus y goes away. Negative 6 minus negative 10 is a positive 4. I can't have a negative variable, so I'm going to divide both sides by negative 1. And I have x equals negative 4. Then I go back and plug it back into one of the problems. So 2 times negative 4 plus y equals negative 6. 2 times negative 4 is negative 8 plus y equals negative 6. solve for y, I'm going to do the inverse operation and add 8 to both sides. Y equals 2. So my answer is negative 4, 2. Now, sometimes it is not possible to eliminate a variable by simply adding or subtracting the equations. When this is the case, you need to multiply one or both equations by a non-zero number in order to create a common coefficient before adding or subtracting the equations. So in this case, I need to look to see if I can multiply one of the equations by a number to get the answer, or to get a common, the same, or opposite coefficient. Here I can tell I can multiply the bottom equation by 2 to make a 4 and negative 4, which are opposite. So I'm going to have just rewrite my first equation over here. 3x plus 4y equals negative 10. 2 times 5x is 10x. 2 times negative 2y is negative 4y. And 2 times 18 is 36. I'm going to add those together. So I have 13x, this goes away, and I have 26. Divide both sides by 13, x equals 2. Then all I have to do is take it and plug it back in. So 3 times 2 plus 4y equals negative 10. So 6 plus 4y equals negative 10. Subtract both sides by 6. 4y equals negative 16. Divide both sides by 4. And y equals negative 4. So I have 2, negative 4 is my answer. Hopefully that helps you a little bit with elimination.